Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you back to the lecture series on course material of Transportation Engineering 2. From the previous lecture, we have started with the next part of our syllabus within the Transportation Engineering 2, that is Airport Engineering. And the previous lecture, we have also seen the introduction of airport engineering, that in terms of the development of airport engineering and its effect in India and the various agencies which have been there for controlling of the air navigation, and then the classification of airports. In continuation of that, in today's lecture, we will be looking at different aircraft characteristics. In that sense, the lecture has been outlined in the form like aircraft characteristics and the influence of aircraft characteristics. Those are the two specific aspects which we will be looking at. So, now we start with the main thing, that is the aircraft characteristics, and within these aircraft characteristics we will be looking at the various type of characteristics like engine type and propulsion, the size of aircraft, the aircraft weight and the wheel configuration, the minimum turning radius, the minimum circling radius, speed, capacity, noise, vortices at tail ends, jet blast, fuel spillage. These are the various characteristics which needs to be considered as far as different design aspects of the runways, terminals or taxiways or aprons or the maintenance units are concerned. And that is why if we have an idea of that what is the characteristic is and how it is going to create an effect, then we can design those facilities. So, therefore, in this same lecture we are going to discuss at the end about the different effects of these aircraft characteristics, and those effects are basically related to the design features which ultimately have to be designed in any of the airport. Those design features we will be discussing in different lectures which are supposed to come after this one. So, we will be looking that whatever we are studying today or whatever we are trying to understand today has its implication in the coming design aspects. So, you may be a little careful so as to look at that what characteristic is going to create an effect at what level or for what particular design. So, in this case in the aircraft characteristics, we will be starting with the first type of a characteristic, that is engine type and propulsion. In this engine type of propulsion, we have to look at what are the various types of engines which are available, which can be used so as to provide the movement of the aircraft, and then what type of movement of the aircraft can be provided, that is how fast or how slow that can be provided, or at what particular altitude that can be provided, or whether it is an atmospheric propulsion system or it is a transatmospheric propulsion system that can be provided. Now, this propulsion may be through any type of engine. We have a different type of engines which can be used for providing the type of propulsion which we are interested in. What we see is that there is a piston engine, there is a jet engine, where within the jet engine again there are different type of the jets available. They are termed as turbojet, they are termed as the turbo propulsion or the ramjet, and then there is a rocket engine. So, all these things, all these type of engines, from the name, their name itself suggests they tries to define that how they can be used. The piston engine, as can be seen or as we have looked at as far as the highways are concerned or as far as the railways are concerned, that these are the most conventional type of the engines which have been used, where they are dependent on the movement of a piston, and with the movement of the piston the amount of torque and power is being generated, and that torque and power is utilized by the vehicle for its movement. So, that is more of a conventional type of engines which uses the fuel, and then that fuel is utilized so as to convert it into the mechanical or the electrical energy. Whereas, if you come to the jet engine sort of a condition, there is that these engines are having a capacity of providing a jet at the back with a high thrust, and this high thrust is utilized for moving the vehicle in the forward direction. So, that is the concept with the jet engine types, and within these jet engine types, then what type of jet is being provided, whether that is a jet which is known as a turbojet, or there is a jet which is termed as the turbo propulsion, where the not the thrust only is there, but there is the sucking of a heavy amount of air, and then with the help of the propulsion system, and then it is being transformed into the jet from the back. That is the type of the situation, where in the case of ramjet we are not using the components of the fuel so as to provide that propulsion system. And rocket engines, you have already seen that they are generally trans-atmospheric conditions, that is, we are leaving the atmosphere and moving into the space, then at that point we require the rocket engines. So, it depends on for what type of movement we are interested in, we can provide the type of the engine. And as we look at this set of type of engines, we move starting from the piston engine to the rocket engine, then the amount of power which they are going to generate is higher in this series, in this order. At the same time, the speed which will be provided for the vehicle is also going to be increasing in the same order. Now, when we look at these one, then what we found is that these can be used so as to provide the speeds as high as 500 kilometers per hour, mostly in the case of the piston engine categories, and then in the case of jet engine categories it may be somewhere around 800 kilometers per hour in the case of turbojet and turbo propulsion systems, and the ramjet condition may go to 1280 to 2400 kilometers per hour. That is the speed with which the aircraft can move, and in the case of the rocket engine it may go to as high as 4600 kilometers per hour. So, that is how the speed may change with the provision of a type of an engine in an aircraft, and that is the type of the category of the aircrafts which we can look at. And these aircrafts may operate at different altitudes. It again depends on the type of the engine and the propulsive power available to the engine as well as to the aircraft or the vehicle. They can be operated at the low altitudes or low to high altitudes or middle altitudes. Generally, when we look at the piston engines, then they can be operated at the low altitudes, where these turbojet or turbo propulsions, they can vary in somewhere between low to high altitudes. Ramjets are around in the middle altitudes. That is the way we are using them. And then this ramjet is also used in missiles, and the rocket engines are used for outside atmospheric operations, because ramjet, as we see that it has a higher speed, and then it can be utilized using the middle altitudes, where there are less chances of the other type of the operating systems being using, with the especially the aircrafts which will be either moving at the low or the high altitudes. Most of the time in new technology conditions, they are the high altitude conditions, then the middle altitude conditions can be used for the operation of the missiles, and that is where the ramjets are being used. Then another thing is the size of the aircraft. Then this size of the aircraft is one of the important things which is to be looked at. It is to be looked at in the sense that there are three components which are going to create an effect in most of the cases of the vehicles, that is its length, its height and its width. Now, here with the in the case of an aircraft, it is not a single main body of the vehicle which we are talking about. We have also to look at the wings which are coming out of the main body of the aircraft, and that is where the overall wing span also becomes important. And as we have seen in the guidelines being provided by ICAO or by FAA, that it speaks of not of the size of the main body of the aircraft, but it talks about the wing span while classifying the airports. So, that is the importance of the wings of the aircraft, and that is where the size of the aircraft at times has to be defined in terms of the wing span. So, we have to look at what are the things which are going to define overall size of the aircraft, and this is defined using certain basic parameters like the fuselage length. Fuselage is the area which encompasses the fuel which is to be transported along the aircraft, which is used along the path. At the same time, it also encompasses the payload, and that is the passengers and the freight that will also be placed within the fuselage length, and this is the length which is provided from the nose of the aircraft to the tail of the aircraft. So, that is the overall length of the fuselage. Then another thing is the gear thread, and this gear thread is the distance between the main gears being provided. Then height is usually taken at the tail, because again in the case of the tail we provide a sort of a wing in the vertical direction, and due to that wing which is provided in the vertical direction, the height increases than the topmost level of the fuselage provided at the nose. So, therefore, the height of the aircraft is taken at the tail. Then the width of the tail is to be examined and is to be computed, that what is the overall width of the tail, because again in this case apart from the main body at the tail, that is the fuselage, whatever is the width of the fuselage at the tail, there is again the two small wings which are provided at the back, and that is why the overall width of the tail which encompasses the fuselage plus the wings has to be considered. Then there is a wheel base, which is the distance between the nose gear and the main gear, because in the case of the aircrafts the wheels are provided at two locations. One is just below the nose where the pilots are sitting, that is what we can understand, that is what is known as the nose. The pilots are sitting somewhere in the nose, and just below that whatever gears are provided, they are termed as nose gear, whereas the main gears are located at the point where the wings are being connected with the main body, that is fuselage. At that particular location at the bottom of the fuselage, whatever wheels are provided and the way they are being connected, that is the location of the main gear. So, the distance between this main gear location and the nose gear location defines the overall wheel base. And then the next important parameter which defines the size of the aircraft is the wing span, and this wing span is calculated near the main gears, where the two wings being provided on the side are getting connected with the fuselage, that is the main body, and if we go along with these wings to the farthest point from one side to the farthest point on the other side, then this is what is the wing span. So, this is how the size of an aircraft is defined using fuselage length, threads, gears, and height, tail width, wing spans, and the wheel base. This is one diagram which tries to define the same things as we have discussed just now. Here we have the aircraft in the elevated condition on which we are looking on it from the front side, and then we have this diagram where it is in the plan, and then this is from the side. So, this is how we are looking at this aircraft, and what we see is that we are providing this particular aircraft with a nose gear, that is this is the nose of the aircraft. So, this is the nose of the aircraft, and this is the location of the glasses of the cockpit where the pilots will be sitting. So, this is the location somewhere here where the pilots will be sitting. At this particular location, just below this one, this is the fuselage body, this body is the fuselage. So, this is nose and this is the tail, and then at this location we are having the wings. So, these are the wings which are coming out like this on this side, as well as there is the wing which is coming out on this side, and that is how the symmetrical design of the vehicle is being achieved. Now, the point is that where these wings are being connected with this fuselage body, at that location whatever gears and the wheels are provided, they are the main gears, and these main gears are provided at the connectivity of this wing with the fuselage, and that is where that is how they are provided at this location. This is for the nose one, and these are for basically the wing gear systems. Here they have been shown below the 4 propulsion systems or the engines being employed on this aircraft. Here this is the location of one engine, this is another location of the engine. Similarly, there are 2 engines on this wing. The engines are not provided in the case of the aircraft within the main body, they are located on the wings. So, whatever number of engines have to be provided, they should be located symmetrically, and in case there is only a single engine, then it has to be placed somewhere here, but generally it is not a single engine condition. We have the double engine condition, and in that case on either of the wing one of the engines will be placed. Similarly, when it is a 4 engine condition, then we have 2 engines on one wing and 2 engines on the other wing. If it is 3, then there is one engine to be provided in the nose area condition. So, that is how we try to achieve the symmetrical conditions of the engine, so that the thrust or the torque or the power which is being generated by these engines is distributed evenly through all of the body of the aircraft. Now, as we are talking here about the size of the aircraft, so what we see is that the distance between the one wheel being provided on this side, the connectivity of the wing on the right hand side with the fuselage, and the distance between the another wheel which is provided on the connectivity of the wing on the left hand side with the fuselage, is termed as gear thread. So, that is the gear thread distance, because now if it is taking a turn, then this is how it is revolving with respect to this point. Then second thing is that the wings are also provided at the tail. So, this is a smaller wing on this side and this side, therefore, we have to look at the width of the tail also. So, this is how we take the distance from this to this point as the tail width. Then the length is from the nose to this end. So, that is what is the length being shown here. So, this is the nose and this is the tail. So, this is the overall length of the fuselage and this is the length of the aircraft. Similarly, the height is taken in terms of a wing which is provided at the back on the tail, and this looks like this in the case of the front diagram. So, this is at the back, we are providing a tail in the vertical direction, and this defines the height. So, this is the height of the aircraft. So, these are the things, and along with this one, then there is a wheel base. As we have discussed, the wheel base is the distance between the main gear which is located here and the nose gear which is located here. So, this distance being provided, this is the wheel base, that is with respect to this wheel, the nose will be moving at a radius of this much. So, this will be taking a turn like this or taking a turn like this. So, this is why it is termed as wheel base. Now, we come to another important parameter of an aircraft, that is aircraft weight and wheel configuration. What is the total amount of weight of an aircraft? That is an important aspect. At the same time, how this load is going to be transferred to the pavement at the bottom is going to be defined by the wheel configuration and the number of wheels being provided. So, what number of wheels are provided and how they are provided is what is wheel configuration. So, in the case of the aircraft weight, there are different type of weights which we can discuss. They are defined as the maximum gross takeoff weight, the maximum structural landing weight, the operating empty weight, the payload and zero fuel weight. So, these are the 5 categories of the weights which can be there, and here they have been designated as A, B, C and D, so as to define what is the correlational aspect between the these all type of the weights, which we will be looking at in a diagrammatic form. But what basically this maximum gross takeoff weight and others are, in the case of this maximum gross takeoff weight, this is the total amount of the weight which can be taken by an aircraft at the time when it is taking off from the runway strip to the air. So, at that point of a time, whatever is the weight of an aircraft, that weight is termed as takeoff weight. And obviously, at this point of a time, whatever is the normal weight of an aircraft, that is without any fuel, without any passenger, without any freight, without any crew, without any other materials being provided within this one, that is simply the weight of the aircraft with its accessories is one weight, plus then it is added to that is the weight of the fuel which is to be carried, then to that it is added as the weight of the passengers or the freight. This weight of the passengers or the freight is termed as payload. Payload means it is a load which is being paid for and from where the revenues have been generated. So, that is the payload, that it includes the passengers and it includes the freight. Then there is a zero fuel weight, that zero fuel weight is a condition when the aircraft is reaching the destination and the fuel is coming to the zero level. So, at that point of a time, whatever is the weight is there, that is the zero fuel condition weight. And then operating empty weight means then we are operating without taking any other load, that is the payload is not there, that is what is the empty operating weight. And we will look at how they changes. And there is another one is like this maximum structural landing weight. As we have seen in the case of the takeoff weight, where it incorporates all the type of the weights which can be there, like the weight of the aircraft, weight of the payload, weight of the fuel, weight of the accessories being provided for the passengers or for the freight, everything is included in this one. Whereas when we talk about the landing weight, as we can understand, when we are landing, there will be passengers, there will be freight, there will be the weight of the aircraft itself, but what is being deducted from the takeoff weight is the weight of the fuel which is being consumed during the journey. So, whatever is the fuel which is being consumed during the journey, that much amount of weight will get reduced and that will become the maximum structural landing weight. Now, the word maximum is coming depending on the size of the aircraft which will be using that airport. So, on the basis of that one, whatever is the biggest aircraft which will be using the airport, we will take the gross takeoff weight and the structural landing weight with respect to that aircraft. So, that is an important aspect, because some of the supporting system designs are dependent on these type of weights. Here in this diagram, we are trying to show the relationship of all these components. As we have discussed, that we have this A, B, C, D and E. If we look at C, D and E, C is operating empty weight, D is payload and E is zero fuel weight. So, here this C is here, this is the empty operating weight. This empty operating weight varies between 44% and 66% of the overall weight of an aircraft. So, that is we can understand that it comes up to this point. If we assume this as a 100% scale, then it will be up to this level. Then we have this D, which is the payload. So, this payload is it varies between 16 and 24% in a normal aircraft where it is we are talking about the passengers and we are talking about the freight. Then we have this zero fuel weight, and this zero fuel weight varies between 6% and 40% depending on the size of the aircraft and the distance for which the aircraft is making a flight. So, that is what is the level, and then there is also some reserve of a fuel which varies with a very small value of 4 to 6%. So, that is what is being shown here in terms of 4 to 6% at this level. So, these are the different components of the weights which will be there. So, this is with respect to the aircraft weight. That is what we can understand is the main weight which is coming in within the aircraft overall weight when it is taking off or landing is the weight of the aircraft itself. This is the amount of the weight of the aircraft itself. This is the fuel which is being consumed during the journey, and this is reserve condition, and these are the passengers etc. If they are being removed, then it is an empty condition and the aircraft is moving with the empty condition. So, here what we are seeing is if we consider whole of this weight, then it is total takeoff weight, that is takeoff weight being shown by A. And if we remove the weight of the fuel which is consumed during the journey, then what we are left with is B, and this B is nothing but the structural landing weight with which the aircraft will be landing on any airport. So, these are the weight and the weight characteristics of the aircraft, and now we will look at the wheel configurations. Wheel configurations, as I have told, is that what we found is that in the case of the wheel configurations, it is going to define how the loads are going to be transferred to the bottom supporting system. More are the wheels, the less is going to be the stress at a certain location, and that is where we require a lesser thickness of the material at the bottom, or we can have the material which can take a lesser amount of loads. So, that is where the wheel configuration becomes important, and there are different types of wheel configurations which are available, and it all depends upon the size of an aircraft, and on the basis of that size of the aircraft we can provide the various type of wheel configurations. Like here what we can see is this is a single wheel assembly. This is a one wheel on the nose, and then there is a one wheel and another wheel at this gear thread, that is the main gear, which are provided below the wings. Then it can be this is another single wheel assembly. In the same case, this is in the other direction. Then we have the dual wheel assembly where we are providing two wheels at a location. So, there are two wheels at the nose and two wheels at this location and two at this location, and the center to center of these will be the gear thread of the main gear, whereas the distance from this to this point is the wheel base. And this is obviously is provided in the case of bigger aircraft where we have to transfer more of the loads from one location to the another location. Within the same one, then there is a further modification that is termed as a twin tandem gear, where the axle which is being provided at the main gear like this is made double, and that is what is a twin tandem gear. So, we have the two wheels at each of the locations, but then we have two sets being provided at the main gear location. And then there is a twin gear system, where in this case we are providing the twin gears at the back at the wing wheels, and then again we are having the gears being provided in the nose area. So, in the nose as well as in the tail area we have the wheels, as well as at the main gear location also we have the wheels. So, these are the different configurations of the wheels which can be there. Now, we come to the another important characteristic, that is the minimum turning radius. This minimum turning radius is defined as while taking a turn the nose gear is steered. As we have seen in the case of the road vehicles, if we steer the vehicle, then the front wheel will be steered, and the back wheel is generally the powered wheel, from where the power is coming to the vehicle. That is the same condition is here. Here the nose gear is steered while taking a turn, and therefore, it makes an angle with the axis of the main gear, because the main gears are provided at the wing location. So, as soon as it is steering, then there will be an angle with which it will be coming with respect to the axis of the main gear, and this particular angle is known as angle of rotation. And the point of intersection of the axis of main gear and the line through axis of the steered nose gear is called the point of rotation. That is the point above with respect to which the whole of the aircraft will taking a turn. That particular point of rotation is to be identified on the basis of the extension of the axis of the main gear as well as of the steered nose gear. And wherever these two extended axes of the gears are intersecting, that particular point is termed as the point of rotation. The maximum angle of rotation varies between 50° and 60°, and the line joining the center of rotation and the tip of the farthest wing of the aircraft is known as the minimum turning radius. This is the minimum value by which an aircraft can take a turn, and any other radius by which the aircraft will be taking a turn which will be more than this one. So, what we have to do is, once we find out the point of rotation, then this point of rotation is joined with the farthest point on the wing on either side, and whichever is going to be the maximum, then that maximum value is going to be the minimum turning radius. We will try to look at this in the diagrammatic form also. Here this is the plan of an aircraft, and this is the nose area, this is the tail, and therefore, there is a nose gear being provided. Then this is a wing, this is another wing. So, there at this connectivity there is one wheelbase and there is another wheelbase being provided at this connectivity, and that is what is the axis of the main gear. So, this is the main gear. Now, as this one is being turned, there is a steering of the nose gear. So, what we see is that instead of this location, as in this case, it becomes steered to this location, and therefore, if we take the axis of this one, it is going in this direction. So, we have this axis, and if we extend this axis now in this form, and we similarly extend the axis of these two gears, then this will be extended in this form like this, and this is extended in this form like this. The location where these two axes are crossing each other, that is this dotted point, this is the center of rotation, means the whole of the aircraft, when it is taking and steering in this direction like this, will be turning with respect to this point. So, that is what is, it is not on the main gear itself, it is away from the main gear like this. Now, at what radius this aircraft will be taking a turn is another point. So, in that case, we take this particular point, and that is the center of rotation, and take the distance of the farthest tip of the wing. So, if we take the farthest tip of the wing, then this is the farthest tip of the wing from this side. So, if we connect this, this is one value, and if we connect this one with this, then this is the another value. The maximum of the two means this one is going to be the turning radius. So, it will be taking a turn with respect to this point, will move like this, and it will move at this particular radius like this. So, that is where the turning radius is equivalent to this distance. If I join this dot with this last point, that will be the turning radius. So, this is the minimum turning radius with which the aircraft will be taking a turn on any airport while it is moving on the ground. So, that is the ground turning radius which is to be provided, and if the size of the aircraft is big, it means it requires a bigger turning radius. If the size of the aircraft is small, it requires a smaller turning radius. In the same form, we look at the another characteristic of an aircraft, that is minimum circling radius. This minimum circling radius is related to the movement of the aircraft within the air. and this is the radius in space which is required for an aircraft to take a smooth turn, and therefore, it is dependent on three aspects like what is the type of the aircraft, that means what type of power propulsion system is available to the aircraft, what is the size of the aircraft, then what is the air traffic volume, and what are the weather conditions. That is going to define this minimum circling radius. And this minimum circling radius is what happens in this case is that this is the total radius which is provided at the top of the airport in which the aircraft will be circling if it is not being allowed to land. So, sometimes you must have seen that the aircraft which are moving at the top of the airport, that is what is the circling radius, and the significance of that we will be looking later. Now, in the case of the speed, there are different ways the speed of an aircraft can be defined. It is like air speed, where the air speed is the speed of the aircraft in air relative to the medium, and in most of the cases the medium remains air. So far we are talking about the atmospheric movements. And then within this one there is an indicated speed. This indicated speed is the speed which is indicated by the instruments on the board. So, whatever instruments are telling on the board is the indicated speed, and generally this is around 2% lower than the true speed of the aircraft. The reason is that it is a relative condition, and we have to look at the effect or resistance of the air, and the effect of that one is to reduce it by something 2%. Further, like in this diagram, what we are looking is that we have the overall speed, like there is a wind speed which is working in this direction, that aircraft is moving in this direction. So, there is certain, and this is the medium, that is air, and the velocity of this aircraft is in this direction. So, if we are looking at in terms of a relationship between the air speed, that is the speed with which this aircraft is moving in the air, the speed which is termed as the ground speed, that is the speed which we are getting while looking at this aircraft from the ground, and the correlation with the wind speed, that is the speed at which the wind is blowing. Then it is termed as air speed is equals to ground speed minus wind speed. So, that is how we can compute the value of the air speed, or that is what is the correlation. Whatever two values are being given to us, we can compute the third one. So, in this case the ground speed is the speed of the aircraft relative to the ground, and the relationship we have already seen is that air speed is ground speed plus minus wind velocity, and if it is Mach 1, then Mach 1 is termed as equivalent to the speed of the sound. So, that is how the speed of the aircrafts are termed. Generally they are being termed in terms of less than Mach value or more than Mach 1 value, and on the basis of that we have the subsonic and the supersonic aircrafts. This is another condition where we are looking at the vertical velocity condition. This vertical velocity condition is nothing but it is the updraft or the lift which will be caused on an aircraft because of a heavy wind which is going in the vertical direction. What has happening is that this aircraft is landing, and therefore, this is the flight path at which it is coming towards the runway strip, and therefore, the speed of this aircraft is air speed is working in this direction. And if we resolve it into two components, then there will be an horizontal airspeed component and the vertical airspeed component. Okay. And then in this case, if the wind speed is there is an updraft in the upward direction, then what happens is that this vertical velocity will be equivalent to the wind speed plus vertical air speed, that is the vector sum of this values. That is another way of defining the speed in this case. Then the next characteristic is the capacity of the aircraft, and this capacity of the aircraft is defined in terms of the number of passengers or the total amount of freight which can be transported using that aircraft. Therefore, it is going to be governed by certain factors, and the factors are obviously the size of the aircraft, then the propulsive power which is available to the aircraft, and the speed of the aircraft with which the things can be transported. Another characteristic is noise. This is one of the big problems in those areas where the airports are being located very near to the developed areas. And the major sources of noises are engine noise, the machinery noise which is more prominent at the time of landing, and the primary jet noise which is more prominent at the time of taking off. So, these are the different components of the noise. This engine noise will always remain, and the disturbances are more severe during takeoff than during the landing, and that is because of the jet. Since the inception of the jet engines, the noise has reduced due to technological advancement. Initially, that jet noise was a very heavy noise, and it was a deterrent factor so as to use the jet engines in those areas where the airports are near to the developed areas. But now with the technological advancements, this noise has been controlled to a lot value. Then another important aspect is the vortices which get formed at the tail, and while the aircraft is moving in the air at a very high speed, and this vortices have the tendency to break the tail if they are very heavy, and if the eddies are being formed at the back. And in this case what happens is that these are made of two counter rotating cylindrical masses which extend along the flight path. So, these cylindrical masses which are counteracting with respect to each other, if the value or the measure becomes more, then they may become the hazardous condition for the tail end also. And these are formed near the tail ends of the wings as well as near the tail ends of the aircraft, where there is a detachment of the movement of the air with respect to the body of the aircraft. The velocity of wind in these vortices may be very high, very high, and this is how it looks like. This is the normal condition of the air, and as the wing of the aircraft is coming in this one, then there is a distortion here where there is a higher movement at the upper side and there is a lower movement at the bottom side, and then it gets transformed in this particular location, and this is what is the point of separation, where it goes in this direction and where this goes in this direction. So, some separation will get caused at this location because of this type of movement and this type of movement. So, this separation is going to create a vortex condition at this level, where this is this direction movement and this is this direction movement, and this is how this is one photograph which has been taken while this aircraft is moving in the air, and this is the type of separation which is coming here as being talked about at this level, where this is going in this direction and this is going in this direction. So, that is some separation will be created at this level, and these are the vortices being formed at this one and this one, and if the speed is so high, if something is being left in this one, will get turned off. Then the next aspect, in the case of those aircrafts where the jet blast is being used, this is the blast that comes out of the jet engine at the rear of the aircraft, and it provides the force which is required for the movement of the aircraft. So, that is required for its movement, but if we consider it in the case where the aircraft is standing and the jet blast is coming from the rear, that is so hot, and it creates a severe condition for the things on which it will be falling. So, the severity is going to depend on two things. One is the height of the tailpipe from the round, and the another is the angle of the tailpipe through which this jet blast will be coming out at the tail end. So, if it is in the upward direction, then it will go up. If it is in the downward direction, it will create a effect on the pavement on which the aircraft is standing, and therefore, there is a need to erect the blast fences which can control the damage to the building or damage to the pavement. Then the next one is the fuel spillage. Fuel spillage is the fuel which gets spilled over the pavement from the engine or from the locations where it is being filled into the aircraft, and this creates an effect in terms of that it may cause the effect on the speed of the aircraft while it is moving on the runways or the taxiways or the apron areas. Now, we look at some of the influencing characteristics of the aircrafts or the effect of these characteristics on the design parameters, like in the case of the very first characteristic, that is engine type and propulsion. It is going to or the size of the aircraft or whatever we have discussed so far, that is aircraft weight and wheel configuration, minimum turning radius, minimum circling radius, speed, capacity, noise, vortices, jet blast and fuel spillage. So, we will take up one by one. The engine type and propulsion, this decides the size of the aircraft, as we have discussed previously, the speed with which the aircraft can move, obviously, the length of the runway, because the more is the speed or more is the propulsion, then the more longer runway strip is required for its movement, so as to take off or so as to land and stop. Then it also increases the weight of the aircraft if the bigger propulsion system or a heavier engine is being provided. It is also creating an effect to the carrying capacity of the aircraft, because as we have seen, it is creating an effect on the size of the aircraft. We are talking here in terms of the load taking capacity. The aircraft which is provided with a bigger engine or a better propulsion system can take higher load. The noise nuisance depends on the type of the propulsion system. The circling radius, if the propulsion system provides a very heavy power, then the circling radius will also increase. That means we require a bigger area for the movement of the aircraft, but at the same time the range, that is the distance up to which the aircraft can move without refueling, will be also bigger if the bigger engine type or a better engine type for the propulsion system has been used. Then the maintenance facilities are dependent on the type of the engine. That is another type of facility which is to be checked on with respect to the type of the aircraft which are coming with different type of engines. Blast pads, etc., they are required in the cases where the jet propulsion has been used. Then in case of the size of the aircraft, it is creating an effect in terms of the load carrying capacity. The facilities like size of apron or terminal area, because whatever is the size of the aircraft, say can carry 10 passengers, 20 passengers, 100 passengers, 500 passengers or 800 passengers. On the basis of that, what are the facilities which needs to be provided, their size also keep on increasing. If there is a bigger size of the aircraft, the bigger size of the apron is to be provided. Apron means the location where the aircraft is standing, and similarly the terminal area size will also increase. Then if the size of the aircraft is increasing, the wing span will increase, and if the wing span is increasing, then it will has its effect on the design of the taxiway width, the separation which is to be provided between traffic lanes, the size of the gates. The size of the gates are means the locations from where the passenger will board the aircraft. That particular location is known as gate. So, what should be the size of that gate is going to be defined on the basis of the size of the aircraft. Similarly, the size of the apron where the aircraft is standing, the width of the hangar gate, the location where the aircraft can be parked or can be maintained. So, that is known as hangar, and the size of that hangar is going to be governed by the size of the aircraft. Similarly, the length, that is the widening of the taxiway on curves, the size of the apron, hangars, aircraft capacity, these are the effects of the length and the width of the exit taxiway, because how much width is to be provided while it is taking a turn, and that is going to be governed by the length of the aircraft. Then height is going to create an effect in terms of the facilities like hangars. Tail width is another characteristic out of the size which has its effect on the parking of the aircrafts and the size of the apron. Wheelbase is creating an effect on the minimum radius of the taxiway which can be provided, and the gear thread is having its effect on the minimum turning radius. Then the weight of the aircraft and the wheel configuration, it has its effect on the amount of thickness of the runway or taxiway or apron pavement to be provided. what should be the thickness of that pavement, the distribution of the loads through the wheels, that is already we have discussed when we discussed about the configuration. Then the generation of revenue, because if we can take more of the load, then obviously the more revenues will be generated. The turning is also governed by the aircraft weight. If it is more of the weight, then the turning may be a little difficult at the sharper conditions. Stability is also governed by the aircraft weight. This stability may be in terms of the support system being provided, or it may also be in terms of the wheel configurations which needs to be provided depending on the amount of weight which an aircraft is going to carry. So, two types of stability concerns can be there. Now, the next aircraft characteristic is the minimum turning radius, and it has its effect on the radius of the taxiway. Taxiway is the connecting pavement which is provided between the runways and the aprons. The position in the landing aprons and the hangars is also going to be governed by the turning radius, that how they are going to be provided within the aprons or the hangars. The path of the nose and the main gears which will be traced on the pavement while it is taking a turn. Then there is a minimum turning radius. This is how it is being defined in this case, that it is a turn center at this location based on the this main gear axis which is coming in this one, and this is the steering gear axis which is coming this way. So, the point of intersection is here. Now, when it is taking a turn, then if it is being provided with a dual gear system at the main axis way, then they will not be following each other. So, that is a thing which we have to look at, that how the turning is going to happen. Then the minimum circling radius, because it is related with the movement of the aircraft in the air. So, therefore, it defines basically the separation of two nearby airports, because this circling radius is a very big radius, and at times if it is related to a very big aircraft, then it may be in kilometers. So, that is why it defines that at what particular distance the two airports can be provided with respect to each other. Then adjustment of timings of landing and takeoff aircrafts will also be dependent on the circling radius, as I have told that some of the aircrafts may be having this as in kilometers. So, therefore, if it is lesser, then there can be a frequent landing or takeoff, but if it is bigger, then the time difference between the landing or between the takeoff will also increase, and it will have its effect on the airport capacity, which is defined in terms of the number of aircrafts which it can handle in 1 hour. So, if this timing of landing and takeoff is increasing, it means its airport capacity will be reducing, because it can handle less number of aircrafts in 1 hour. Then similarly, it also has its effect in terms of the zoning laws, which is related to the height of an obstruction being provided in the adjoining areas of that airport. So, up to what particular height the constructions or the developments can be provided, that is also going to be dependent on the circling radius of an aircraft. So, within this range, the buildings or the other constructions should not go up to a height which can create a problem to the circling radius or the aircraft. Then speed obviously reduces the journey times, and it also helps in increasing the frequencies of operations, means there can be more operations within an hour if the speeds are more, and therefore, it helps in improving and broadening the air network system. That is the effect of the speed. But the speed is not directly creating an effect in terms of design variables, but it has a effect in terms of the cruising speed with, not the cruising speed, but the speed with which the aircraft is landing. At that particular speed is used for designing of facilities like taxiways or the exit taxiways, that is from the location from where the aircraft will be coming from runway to the taxiway. Then capacity is another characteristic which creates an effect on the processing terminals, that is what type of facilities needs to be provided. It also creates an effect on the passenger and baggage handling facilities to be provided on the airport. It is dependent on the capacity of the aircraft to handle the passengers, how many passengers or the cargo is coming. Cargo processing time is also related with the capacity of that aircraft, and the type of the equipments which are needed is also dependent, and the number of equipments which are also needed is also going to be dependent on the capacity. Then the size of the apron which is to be provided is dependent on the capacity of the aircraft, because this is directly related to the size of the aircraft. The noise is having its effect in terms of the sleep disturbances or startle, annoyances to the people, or the health risk or the deafness or the heart attacks, etc., to the people who are living in the adjoining areas of the airport. There can also be the effects in terms of loss of concentrations or attentiveness. These are general effects of the noises in any of the locations. Vortices at the tail ends has this effect on the vortices, and that is the wing vortices. There is stresses at the joints with the fuselage is the location where the problems will be, and the pressure on or under the wings producing the lift or the drags. That is another problem associated with vortices. Finally, in the case of jet blast, this is inconvenience or discomfort or even the injury to the passengers if it is not properly located, and the weak velocities of the hot exhaust gas which will be coming out at the back may harm nearby aircraft also if the parking is such. Finally, it is a fuel spillage which is seriously affecting the bituminous pavement, and it may cause the slip of the wheels. These are the some of the influencing airport characteristics, aircraft characteristics, which can create the effect on the facilities being provided on any of the airport. So, in today's lecture, what basically we have seen is that the different type of characteristics are there of any of the aircraft, though the amount may change with respect to the size or the type of the aircraft, but the characteristics will remain the same. And finally, what we have tried is to see the effect of those characteristics on the design features or the facilities which needs to be provided on any of the airport. With this one, we will be stopping at this point, and we will be meeting in the next lecture. Till then, goodbye and thank you.
Thank you.